Hello. In this example, we want to factor f of x equals negative x to the fourth plus 16x squared and find all zeros of the function f. Now, to do this, you could try and use synthetic division, but notice that the function itself, negative x to the fourth plus 16x squared, there's something in common between the two. And when you're trying to factor something, the first thing you always want to look for is a common factor. So notice between negative x to the fourth and positive 16x squared, what's in common? Well, if you said x squared, you're correct. So we can have an x squared. But I also don't like having a leading coefficient that's negative, so I'm actually going to factor out a negative to go along with it. So really, I'm factoring out a negative x squared. Open in parentheses. So negative x to the fourth divided by negative x squared is positive x squared. And positive 16x squared divided by negative x squared is just minus 16. Now notice that negative x squared cannot be factored any further. However, you should also notice that x squared minus 16 is a difference of two squares, because 16 is a perfect square. So instead, we're not done. So what we need to do is factor this just a little bit further, making this negative x squared times the factorization of x squared minus 16. Now remember that the factorization of a squared minus b squared is a plus b times a minus b. It's the multiplication of conjugates here. So the factorization of x squared minus 16, well, ask yourself what's the square root of x squared? The answer is x. Plus, what's the square root of 16? 4. And then rewrite this again, but instead of a plus, use a minus. And there you go, that's the factorization. Negative x squared can't be factored any further. X plus 4 can't be factored any further, and x minus 4 cannot be factored any further. Therefore, none of this can be factored any further, which means this is the factorization of negative x squared times, negative x to the fourth plus 16x squared. Now, I do want you to realize one thing, that we can actually find all zeros from this. Okay, so the zeros are just wherever each factor is equal to 0. That's a very terrible curly bracket. There we go, that's better. So what we can do is we can say negative x squared equals 0. We can say x plus 4 equals 0. And we can say x minus 4 equals 0. Divide by negative 1 and then use the square root property means that x is equal to 0. Now technically plus or minus 0, but you know, it's all just 0. Subtract 4 means x is equal to negative 4, and add 4 means that x is equal to positive 4. And so because of that, the 4 zeros here are negative 4, the 3 zeros here are negative 4, 0, and 4. And those are all of the zeros. Now, eventually we're going to talk about how the highest degree, or the degree of the polynomial, is actually the number of zeros that you can have, the maximum at least. And notice that I have 3 here, but I did say 4. And the reason I said 4 is because technically this 0 is used twice. Because this x squared equals 0 simply means x times x equals 0, which means x equals 0 or x equals 0. Now notice that it's used twice. And that's called a multiplicity. Okay, multiplicity simply means the number of times a 0 is used as a 0. So that means that because you have an x squared equals 0 here, that it had a multiplicity of 2. Now this all in purple here is just kind of a sidebar for this problem. Alrighty. Well, y'all have fun. I'll see you next time.